Hi, so in this video I just briefly wanted to show something about the Python API to sort of give you a primer on how to get started with it in case you want to do some custom cool stuff. So on the website here you can basically find all the different methods that have been exposed. I'm going to be showing you one of them so that you can check it out. I also show how these are used throughout some of the things you have access to with the plugin. But the example that I wanted to show, which I mentioned in an earlier video, is essentially if you have, let's say, complex network with various ROPs all over the place, perhaps even custom nodes that do things, and you want to make sure that, for example, whenever this node cooks, whenever it writes something to disk, you can check out the file, before it tries to write, or it adds a file after you have written it to disk. So that's fairly straightforward with the ROP because it has these nice pre-render script, pre-frame script, post-frame script, post-write script, and post-render scripts that you can add custom Python to. And as you can see, what I've done here is I've just added 2 lines of code that essentially do all the work that we need to do. So in the pre-frame script, which gets run before the frame gets computed, what it does here is it basically says import P4Houdini, which is the module of the plugin itself, and then it says P4Houdini.node file automatic, and then it passes the node that is currently cooking. And if we then look at the documentation here, we can see that for node file automatic, it says for the given node, check out or add all files found in the known parameters described in P4 node checkouts. So like I mentioned in the previous video, the P4 node checkouts is essentially this file here. And then for the ROP geometry, you can see that it's going to look for the parameter called sub output, and that is the file that it is going to try and add or check out onto the repository, which in this case is this one here. So as you can see, this gets run every time before a frame gets computed. So in the case that you have a file that's already on Perforce, that's write protected, this is going to check out that file for you, allowing this node to properly save to disk. And then once it is done, it is going to try and add or check out that file again after the post-write script. And the reason I've put it in both is because this will prevent any sort of write permission errors in case that the file is already on the repository but not checked out. And what this line here is going to do, which once again is the exact same line of code, what this is going to do is it's going to add the file after it has been written in the case that it is not yet tracked on Perforce. So to check it out, we're going to take a look at Perforce in its current state. You can see I only have a default change list, but after we hit save to disk here, you can see that it is going to cook the node. It is also computing some Python in the background. And then when we go to Perforce, you can see that it has created a new change list, which is going to be named with the default change list description that you can add in the preferences. And you can see that all of these files are now perfectly tracked on Perforce. Now, let's say we're going to hit submit on these. We're just going to not change the description for now. Now you can see these files are on here, right? If I now were to try and hit save to disk, if these are disabled, we're going to get a permission error. This node is going to throw an error saying I cannot write to this file because it is write protected. But because we have these 2 lines of Python here, we're simply going to hit save to disk. And what you'll see now is it's not adding the nodes, but it is going to actually check them out, as you can see here, allowing us to very easily work like that in the plugin. All right, so that's one thing I wanted to show you. You can take a look at the other ones here to see what else you can do in your own time. But I also briefly just wanted to show you that, these shelf tools here, they are also just simply using that exposed API, showing you how to revert a file, how to do other things. You can even go into the actual files of the plugin itself that you download from GitHub. And for example, take a look at the op menu. And what this op menu here is basically an XML describing the right-click menu that you have on nodes. So in the case, for the P4Houdini menu, you can see that we have add checkout on an HDA, we have added change list on an HDA, and various other things. You can, for example, also see that for the parm menu.xml, oops, that's the wrong application. I want to open it in Sublime. You can see that the add checkout for the parameters is also simply importing the P4Houdini module It's grabbing the parameter that we're right-clicking on. It's then grabbing the file, um, evaluated file path of the parameter, and then it's simply asking the plugin, hey, p4houdini.file checkout, and then that file. That's all it is. It's fairly easy to add this code to already existing UI elements of Houdini. It is very easy to add it to your own custom nodes, or if you really wanted to, you could, for example, also have a Python SOP that inside of your network, evaluates and cooks some code regarding the plugin. You can add it to shelf tools, you can add it to your custom UI, whatever else it is. If you have questions about the API or have any requests, please let me know and I'll be happy to add them.